So basically the quadratic formula is if none of these, all these methods we looked at for our warm-up, if none of these methods are going to work for us, then we fall back on that quadratic formula. Again, that quadratic formula must be in the standard form. That means what? That means it has to be equal to 0. If you have an equation that is not equal to 0, then remember you have to set it. Okay? You have to set it equal to 0. Do you see anything in this equation or this formula that we've seen previously that ties in with our other things? What do you see that you've seen before? The what? The
But it was on the back like a different word along.
The radicals. Oh, and y'all will need your radicals out for when we do this today. So do you see the plus minus? Okay. Do you see the axis of symmetry up there? What's our axis of symmetry? How do we find our axis of symmetry when we have an equation? C is y-intercept. How do we find that axis of symmetry? Right. You see it? You see your negative b over your 2a. Right? So all of this stuff ties together with what we have been doing with our quadratic. So you can kind of see that embedded in there. So we're going to take our warm-up. So we had factored out that 3, and then we were left with the 4x squared minus 3x plus our 5. We're going to find the solutions. So if we're going to find the solutions, what does it have to be set equal to? 0. So we're going to set that equal to 0. All right, you already tried on your warm-up to use your x method, and it did not work. So this is a good example of why we fall back onto that quadratic. So what you would do is we're only going to focus on the inside because the 3 doesn't have a variable, so it doesn't affect the solutions. So we always establish what our A is, what our B is, and what our C is. And remember, we did this when we were graphing, right? You distinguished what your A, B, and C were. What is our A? What's our B? And what's our C? Why is this not? It's 5. So then all we're going to do is we're going to take our A, B, and C, and we're going to just drop them into the formula where they need to go. So I'm going to do that negative, and what's my B? My B is a negative 3. Remember when we did this axis of symmetry, what happens when we have that double negative? So kind of remember that, and then plus or minus the square root of our B, and we're going to square the B. The B is a negative 3, and we are going to square that. Remember, squares are always positive. Your B squared will always be positive. Oops. Anybody tell me why? Why will the B squared always be positive?
Because the times itself is positive. Negative times negative is a positive.
Yeah.
So even if you have a negative B, it'll still be a positive.
Yeah, right? So remember that. I see that mistake over and over and over again. Okay, and then minus our 4. Our A was a 4,
C is a 5.
and C was 5. All over that 2 times our A of 4. Okay, so it looks like a jumbled mess, right? Especially on the inside. So what we're going to do here then is we're just going to simplify the inside down. We'll just work with the radical, and then we'll bring back in our b and our 2a down here. No, you can use the calculator for adding that up. So let's do the inside. No, 2 times 4. All right, so 3 squared is 9. Now let's multiply all this together. I've got a 4 times 5, which is 20, and then 20 times a negative 4 is negative 80. So let's keep going with that. 9 minus 80 would be a what? Negative 70, negative 71. Let's see if I can get that. Negative 71. Okay. Now, is this in simplified form? No. Why? Because it is a negative. Now, think back to when we did these. How do we split this up? Well, for the negative, what do we do here? We do the negative 1 times the square root of 71. And our negative 1 becomes what? I'm sorry, square root of negative 1 equals what? I. So that comes out as I. And can we simplify 71 down? Was it on our list of, is there a perfect square inside 71? No, so that'll stay under. Okay. So let's come back over here now. So now we have the 3 plus or minus I times the square root of 71 over our 2 times 4, which is 8. Yeah. Now, when you get to this point, if you can reduce, since you have a denominator, you're going to have fractions, right? So if at this point you can reduce numerator, denominator, this is when you would do it. But don't reduce until you get to your simplified radical form. And when you if you have fractions and you're reducing, remember that is not a 71, right? That's a square root of 71. So once you have simplified this down, you cannot touch what's on the inside, okay? The only things you can reduce is what's on the outside here.
So that's your final answer?
Uh-huh. In this case, this one is, yes. So this would be your answer. So you have 2 answers, right? You have the 3 plus the I times the square root of 71 over 8, and then you have the 3 minus the I times the square root of 71 over 8. So let's check your steps on this one. So we set it equal to that 0. Remember, it has to be in that form. And you establish 2 is A, B is negative 16, and C is 27. And then we subbed those in. So again, you ended up with a double negative here, so that's going to bring back a positive. In here, when you square a negative, it's always going to come out to be positive. So that should have been a positive, what was that, 256? 256. And then minus your 4, your A of 2, and your C of 27. So we look at the inside, and we simplify that. Yeah, so here's your 256. We multiply those together. So you would multiply the negative 4 times the 2, which would be negative 8, and then negative 8 times the 27 gives you a negative 216. So simplify that even further, and we get that square root of 40. Now, square root of 40, what can we do with that? Yeah, this is one of those ones on your list, right, that we can, what's the perfect square inside of it? 4. Very good. So square root of 40, we break down into the square root of 4 times the square root of 10. So the 4 becomes 2 on the outside, and the 10 stays on the inside, right? So now we have 16 plus or minus 2 square root of 10 over our 4. Now, do you see some reducing that can be done? No? Yeah, I do. I see. All right, so when you reduce your fractions, a good idea is to split them up. So you would do your 16 over 4 plus or minus your 2 square root of 10 over your 4. So what can we do with 16 over 4? And that would give you a 4. Now, what can we do here? This is a fraction, so can we reduce it though? Yes, we can. What divides into both of them? 2. So 2 divided by 2 is? And then, yes, and 4 divided by 2 is. So then that would be the plus or minus square root of 10 over your 2. So here's what we did. We set that equal to 0. Remember, if it's not set equal to 0, you have to do that. You have to move your terms. Now, we took our formula and we subbed in those values, our B, our A, and our C. Then focus only on the radical. Just kind of focus on that till you get that in simplified form. So we subtracted the 256 from the 216 for the 40. And remember, if you look on your little simplified radicals, that one can be simplified more. So we came over here and broke that into the 4 and 10. And then the 2 came out, 10 stayed in. Then bring that back in with your B and your 2A down here. And then you can see it, when you're looking at that, you can see that you will do some simplifying. It's easier if you split them up and do it that way.
So you just leave the 10?
So you what?
You leave the 10, you don't simplify it?
No, because 10 is done. Yeah, you're done with that. Because we don't cancel what's under the radical. Because that's not really a 10, right? It's a square root of 10.